Networking, Part 5. In this nugget, we conclude our discussion of networking, and this is part 5, where we start off with a brief discussion of the difference between a work group, a domain, and a tree. And then we also talk about what DNS is and how it's useful. We also take a look at the various network configuration components that you can access through your network properties. And then we also look at the browser configuration, especially as it relates to configuring whether or not you allow scripts to run. We take a look also at proxies, which is also part of your browser configuration, and we discuss what proxies are and how they're useful. And then finally, we conclude with several troubleshooting steps. Now, before we get into our discussion of DNS, I first want to return to this diagram, which we saw in an earlier video where we talked about this as the peer-to-peer network model. That is certainly what this is, but from a Windows perspective, if you were to configure your computer to be involved in this, then you would right-click My Computer and choose Properties, and you would call this a work group environment, where you'd go to the computer name. And notice that we're in a work group right now. If I click on the Change button, it says we're in a work group. Now, by default, Windows XP and all versions of Windows really will just call it work group. You can call it anything you want to call it. I can call it XYZ, and it'll still be a work group. Conversely, if I go to a different scenario here, my client server environment, in Windows environments, this will be my server, and that's normally going to be something like an Active Directory server, which would be part of what we call a domain. So if I go back into this and I wanted to join a domain, then I would enter in the name of that domain, like AccuSource, might be the name of my local domain here, and then I would click OK, and it would ask me to enter in credentials of someone who has the authority to join this to a domain. So I'd have to enter in administrative credentials and then OK and OK a couple of times and close all of this up. Once I do that, it'll prompt me to restart the computer, because you have to restart if you join a domain or if you change your membership in any way in this interface. And then obviously up here at the top, if I decided I wanted to change the name of this computer, I would do so there. DNS makes me think of parenting. For example, when my kids come to ask me a question, I might know the answer, or I might not know the answer and have to forward it off. So for example, they'll come to me and they'll say, "Dad, can we have some ice cream?" My answer is, "I don't know, go ask your mother." "Dad, can we play at the neighbors?" "I don't know, go ask your mother." "Dad, can we go to the mall?" "I don't know, go ask your mother." But if they say, "Dad, can we have $20? The answer is always no. So see, some things I know the answer to, and some things I have to forward off to some other party, normally the boss, the mother. So what I do here is I kind of equivocate that to DNS. You see, here we have a DNS client, and this can be just any operating system, but this client wants to go to www.west.cbtnuggets.com. The thing is, this client, when they try to open that up in their web browser, they don't really go to that name. What they need to have is an IP address, because we don't really connect to names. It just looks like we do. I can go to a web browser and go to Microsoft.com or something, and it says Microsoft.com right there in the address bar. But I'm not really connecting to that name. I'm really connecting to an IP address. It just shows me a name because it's making a concession for us weak-minded humans. You see, I can't just memorize the IP addresses of all the web servers on the internet. So, for example, here, if I wanted to go to CBT Nuggets website, I could actually enter in the IP address in the browser address section. I could just enter it in this way, and voila, there I go. Now, I just happened to have that information, so I knew where to go. But I don't know what Microsoft's is or any of the other websites that I'd want to go out there on the internet. Heck, I don't even know the IP addresses for my own web servers right now. I guess I could look them up, but I can't remember them right offhand. So what we have to do then is we have to use other servers that will be able to be a kind of a phone directory or a phone book for us to be able to get us information so that we can find the IP address and get to the appropriate server. Now let me take you through the jet tour of how this works. First of all, I'm assuming Windows here, but this client here, which might be Windows XP or something, has a cache, and this will hold recently found lookups. So if I've been to, let's say, www.west.cbtnuggets.com in the past, and that's where I want to go now, then it will remember that I've been there in the past, and it will have that translation. It'll say www.west.cbtnuggets.com is 128.242.116.210 or something like that. And then in my browser, it'll actually take me there. My browser will say that name, for example, but it will actually go to that IP address. Now, there's also a hosts file that is a plain text file on your computer that's loaded into the client cache at startup, and you can pre-populate that with commonly found or commonly resolved names. don't really need those much anymore, but that's how the early internet got started, was with those text files on local computers. Now, if I don't have that information in my cache or for my host file, then what I need to do is to ask my own DNS server. Maybe that's my nuggetlab.local DNS server, which is my private DNS server for my own network, so I can find other computers on my own systems. Well, it will also look at its server cache, and it also has a cache file that it can use. And if it can't find it either, then it needs to go to a number of different locations. It goes out, first of all, to other internet servers. Now, I don't have it in the diagram, but realistically, it's probably going to go to whoever our configured ISP is. Yeah, because our ISP is probably doing lookups all the time from other internet servers, and it might already have that information cached, so it doesn't have to do a whole bunch of other lookups or forwards. What it'll do then is return the answer to my nuggetlab.local server, pass it back to my client, and then my client will be able to, by IP address, go directly out to the internet and down to the web server it's looking for. But if my ISP doesn't have it either, then what happens? Well, the ISP then has to look up other DNS servers that might know. It's kind of a word of mouth sort of thing. So the first thing it does is it goes to the top level domain servers, which are usually designated by a dot. Oh, look, I kind of made a smiley face, only it doesn't look very smiley. But anyway, these are known as the top-level domain servers, where it'll say, heck, www.west.cbtnuggets.com. I don't know. Ask somebody else. But it'll say, I don't know this, west.cbtnuggets.com, but I do know where .com servers are, so let me forward your request on to them. Now, let me point something out here, by the way, as well. The leftmost portion of this fully qualified domain name, this portion is known as the host. I'm looking for a host by the name of www in the west.cbtnuggets.com domain. So it says, I know where to go to get a .com server. The .com server says, hey, I know where cbtnuggets.com is, but I don't really know West, so let me send you down to CBT Nuggets. They're going to get closer answer for you than I can. CBT Nuggets says, well, I know where West is, but I don't know anything about this host, this www business. So it sends you down to the west.cbtnuggets.com. West says, hey, I happen to have a CNAME record, also known as an alias, for www.west.cbtnuggets.com, and its IP address is 128.242.116.210 or something. Well, then, through this series of referrals, we've finally gotten our answer, which makes its way back to my DNS client. And now this DNS client, behind the scenes there, will actually be looking for the IP address of this server instead of its name. Again, it shows up as the name in the browser. In reality, it's connecting to that IP address. All right, then let's go ahead and take a look at how to configure our network connections. Now, you may not have My Network Places on the Start menu, so I'm not going to show you the main way to do that here, but if you did, you'd right-click and choose Properties. I'll just go to Control Panel, which most everybody has, and then I'll go here to Network and Internet Connections. From this point, I'll go ahead and go down here to Network Connections. Now, within this, I see a number of different network connections. Some of these relate to VMware, which kind of installs a virtual network card, if you will. There's also my firewall connection, which rarely, if ever, does anyone use that for real networking. Then here I have the physically connected connection that I use to go to my network. So I'll right-click on this item and choose its properties, and let me describe what some of the things are in here that we see. First of all, there's Client for Microsoft Networks. This allows me to be a client to something like a server or any other host on the network that has a share for me. Like if there's a shared folder up on a server or a shared printer somewhere, this is what allows me to make a connection to that share. And then this VMware Bridge Protocol is something that VMware installs on my computer in order to allow my virtual machines to communicate on the network. We don't need to be concerned about that because, of course, that's vendor specific and not part of the A+ exam. But here we have file and printer sharing for Microsoft Networks. This is a pretty important one to have because if I have a printer on my local computer that I want to share to other people, I have to have file and printer sharing for Microsoft Networks. Now, this is already installed by default as well as this client, so I don't really have to do anything other than just let it happen. The only reason why I might want to remove this item is if I wanted to add a little extra security and I knew I did not have nor ever would have anything that I wanted to share. Then I could simply uninstall this one item and nobody could ever make a connection using conventional means to my computer. You know, hackers can always figure out other ways, but using conventional means they wouldn't have that. And then we have the Quality of Service Packet Scheduler. I don't think we'll see this in the exam objectives either, but this helps to prioritize network activity according to, of course, a priority. And then there's TCP/IP here in the Internet Protocol. Now this is one we do need to spend a little bit of time on, so let's go ahead and take a look at the properties of this item. By default, these will always say obtain an IP address automatically and obtain DNS server address automatically. This means that they're going to receive their configuration from a DHCP server. And to illustrate that best, there's two things we can do. Number one is to show what we would have to do if we did not have a DHCP server, and that is to use a specific IP address. And then we would enter in, 10.10.9. Or whatever the IP address is. There will, of course, in most corporations, and in all corporations, be some kind of a standardized set of IP addresses that we would have to use in this, because we wouldn't want to have conflicting IP addresses on the network. Remember that with IP addresses, only one host can have this exact same IP address and whatever the subnet mask is at any given time. So 255.255.255, I can use a Class C address, even though it's a Class A address scheme. I can kind of break it up into Class Cs like this if I want. And then I can of course, enter in the default gateway, which is the IP address of my router, and maybe it's 10.10.9.1. And then any destination traffic that I have that is for a different network would of course go through my default gateway. Then we have the DNS servers. This is really important to have if you want to browse the internet, and in most corporations as well, it's important if you want to find local resources also. For example, if I want to find a file server, then it's going to have an IP address. Well, the DNS server is probably going to have an IP address, or will have an IP address for that file server. So that will have been registered appropriately, and I'll need to identify my DNS server, which might be 10.10.9.2 or something like this. And then if I have another DNS server in case this one's down or caught on fire or something like that, I can enter in a different one, 10.10.9.6, for example. Or in some cases, you might enter in the alternate DNS server of an ISP, so that if you only have one local DNS server to give you local access to resources, but you still want to access the internet if it's down, you could enter in the ISP's address instead, and you'll just have to check with them to see what that address would be. However, it would be a public IP address, whereas all the rest of this that we're using so far is private. But of course, it's better to use these automatic options like I've reconfigured here, because that way you don't have to take the time and effort to manually enter in all this information. Plus, it's subject to human error. So it's better to use DHCP. And let me show you here. I've got a DHCP server. This is a Windows Server 2003 DHCP server, but in smaller networks, you might just have a network device such as one of those Linksys access points like I showed you earlier in a previous nugget when we discussed wireless networking. For this one, I can look at the scope, and if I choose the properties for it, I can see that I'm issuing addresses between 10.10.10.1 and 254 here, and I'm using a Class C subnet mask. I have a lease duration, which means that the lease is good for 3 days, and if the client has not come on the network to try to renew their IP address within 3 days, then it will expire, and that IP address, whatever they've received, will be given back to the pool and allowed to be leased from some other computer. And then if I want to know where my actual leases have gone, I can go up here to address leases. It shows you which clients are leasing any given IP address at the given time. And what really happens with this, by the way, is that when this client here tries to get an IP address, it sends out a discovery packet, and just think of DORA for the first letter for all of this. It sends out a discovery packet saying, hey, is there a DHCP server out there? Then the DHCP server says, yes, here I am, and I'm alive. I'm going to send you an offer of a specific IP address, so that's O in DORA. And then this client here will say, okay, I like that IP address. I'd like to request it and all the configuration that went along with it. That's the R in DORA. And then A is for acknowledgement, when the DHCP server sends back an acknowledgement that says, okay, this IP address and its configuration is yours. Now, if you can't get a DHCP server, you're going to get a strange IP address. And this is a range of addresses that Microsoft owns and makes available to their current Windows clients in the event of an unavailable DHCP server. Now, since it's going to give me a 169.254 address range, that's not going to do me much good if the rest of my network is on, say, 10.10.10. something. But what that does give me is at least an address. Any other computers that are on that same PIPA address I'll be able to communicate with on my same subnet. It's also an unroutable range, by the way. But the other advantage is at least it loads my TCP/IP stack, and it will periodically send out a discover packet to try to find a DHCP server just in case one has come back online. Now, if I want to have a live and working IP address in the event of a failed DHCP server or an unavailable one, and I don't want a PIPA, then I can go to alternate configuration and manually fill in all the blanks here. Now, we see that we have all of these things we've already discussed in previous configurations, what they are. One that I haven't really addressed is a Win server. This resolves NetBIOS names, and NetBIOS is a name registration service function that Windows computers do. And these are flat names instead of DNS names, which are dotted names, which would be like, client1.nuggetlab.com or something like that, whereas wins would simply be client1. That would be a flat namespace. Now then, having returned here to the basic adapter properties, you also need to know how to upgrade this connection if necessary. The upgrade really wouldn't take place in any of these things so much as it would with the drivers for this specific network card. You can go in through Device Manager, or you can go here to click on Configure. And once you've gone in here, you can locate the Driver tab. From here, you can then update the driver and provide the location of the new drivers that you've probably downloaded from a vendor's source. And that whole driver management function there is much like we've seen for several other devices in this series. Okay, so once you've gone ahead and configured your network card, you've got the updated drivers, you've got TCP/IP configured properly, and everything's working all right, really you've pretty much established a connection. If you have a physical connection to the network and there are resources available, you're connected. So as far as the A+ exam objective is concerned, making a connection, whether it's wireless or wired networks, either one, you properly configure everything, and if everything else is in place, you're done. So it's not that hard in that respect. But one thing I do want to revisit, however, is something we started to talk about in a previous nugget, and that was where we went into permissions. Now, we went to, in the file systems, when we talked about NTFS, we saw that we can assign NTFS permissions to allow or deny certain people to access a given document. Now, we're going to take that a little step further and talk about networking and accessing files and folders and those kinds of resources. You see here, we've got sales meeting notes, and we want other people across the network to be able to read what we had in these sales meeting notes. So if I double click on this, what do we want people to do? Sell, sell more, and sell, sell, sell. So hopefully everybody will be able to remember that. So what we want to do now here is to share this with other people, and I can right click on this and choose sharing and security or properties. By clicking sharing and security, it would have simply taken me right to this same dialog box, only it would focus on the sharing tab. And then now I share this folder. I can give it a share name that's different. By default, it's the same name as the folder, but just to your preference, whatever you want to do there. And then I can say I want the maximum allowed number of people to access this folder. Now, this is Windows XP. If this were a server operating system like Windows Server 2003 or Windows 2000 server, then it would be unlimited. It'd only be really limited to the available network resources. However, with client operating systems like Windows 2000 Professional, Windows XP of any version, and so forth, well, here you can only have a maximum of 10 people connected. Now, the maximum allowed here is 10. It's kind of hard-coded into Windows. You don't really change that. You can change that to a different number of users if you want. Notice that, again, if I click the up arrow here, I can't go past 10, but I can go down. Maybe I only want 5 people at a time to be able to access this. Now then, there's also an issue of permissions here. Let me click on that. By default, anytime you create a share, everyone has read access to it. After all, you're creating a share so people can see it, right? So that would kind of defeat the purpose if I were to take that away directly. Although certainly there might be cases in which I would not want everyone to be able to see this, and then of course I can adjust this as necessary. And then I might just remove everyone here by clicking the remove button, and then add in only a security group or users that I want to be able to have some level of access here. Now, when it comes to security groups, let me briefly address that because it's not really an A+ exam objective, but for context, it might be helpful. In corporations, normally I'll have security groups that are created on a domain controller somewhere or some other kind of an authentication server. That security group will have a listing of people in that group that have something in common. For example, the accounting group might contain all of my CPAs. My research group might contain all of my scientists. The IT group might contain all of my help desk folks and network administrators. So you see, the groups might have a lot of different things in common. In this case, maybe I might have a sales group that would contain all of my sales people. And then I would just simply click on add, and I could type in sales right here, and it would then add that group in. And that's very commonly how file permissions and folder permissions are granted in terms of share or NTFS permissions. Now, in terms of the permissions here, maybe I've got somebody else that I want to be able to have change permission. Like this, everyone, they can only read the documents, but they wouldn't be able to make any modifications to any of the documents. Maybe I want to add a user named Clyde here, for example. And I want Clyde to not just have read access, but I also want him to have change access, which means that he can open up a document and make changes to it and save it, or he can create new documents in there and save them and have pretty much the same kind of control he would have on his own computer with these documents. Now, the difference here between change and full control is full control would also allow him to change the permissions on the file, on files inside of this folder, and he could then, deny access to certain people that he didn't like, maybe, or something. Or he could add additional permissions to additional users or groups in here if he wants, much like I'm doing right now. So then we'd simply OK these things, and we now have a share that has been created. Now then, what we're looking at here is just another computer. I could do this, what I'm about to show you, from any Windows XP computer, any Windows 2000 computer, just about any version of current Windows. This happens to be my server, but I want to make a connection across the network to that share that we just opened up. So I'll whack whack, and then the name of the computer is nlab client. Hopefully I'm remembering that right. And then I want to go to the projects share over there. Now notice that it kind of automatically filled in some things for me. That's because if it detects that there are shares over there, it does something called crawling, where it kind of creeps over there and looks to see what it is that I might want, so I don't have to manually type it in. I just click on projects then, and guess what? Voila. I am now connected to this sales meeting notes, and I can crack this thing open and see what my new assignment is, sell, 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 and we're good to go. Now, from the user's perspective, we can't really expect them to memorize all the names of the servers in a corporate environment and the names of all the shares and get to them the way I just showed you there. So what we normally do is we, as administrators or help desk folks, will map drives for the users. Now, we can do that a couple of different ways. If we happen to be at their desktop and I see this share right here, I can just right-click, choose Map Network Drive. That's kind of the easy way. It gives you a graphical user interface to be able to do this. Otherwise, what I might do, and of course you can just choose whatever available drive letters you have, but other ways that I could do this, and what more likely to happen in the corporation, is for a logon script to occur, or to be able to do this from a command line. And for that, I would just, of course, go to a command prompt. So I'll go to a command prompt right here, and the way we would type that in would be net use, and then the drive letter we want, let's just choose R for lack of a better idea there, and then whack whack, nlab client, whack projects. Press enter, and now I've got a drive letter R, which you can identify right here, and it allows me to gain access to that resource. Now let's talk a little bit about browsers. If you want a more up-to-date browser than the one you have and you want to upgrade or install one, you can always go to a vendor such as Microsoft, or you can go to Firefox.com and get one of the two most popular browsers, and that's what I just mentioned. The first one is Internet Explorer, which we currently have installed here, and I've just got the one that was installed with the operating system. I can check the version of it by going to the help system and then selecting About Internet Explorer, where it identifies exactly the version that I've got. That might be useful information if, for example, there's a security vulnerability against a given version, and I need to know if I've got one of the older versions and it might need to be updated. By the way, I haven't installed it here, but Internet Explorer 7, much like Mozilla's recent versions of Firefox, also give you tabbed browsing, which I like quite a lot. This allows me to open up multiple web pages in a single window without having to open up many separate windows instead, which kind of get cluttered on the taskbar area and so forth. And then as far as browsers are concerned, another thing you'll need to know about is to go to your browser and choose Tools, and then Internet Options if you want to configure the security settings. Now, primarily we want to go to the Security tab here, and notice that there are several pre-configured zones that we can use. There's high, medium, medium, low, and low. Of course, the medium one here is the default level. If I want to customize how it's configured, I can choose Custom Level. And then I can say I want to or I don't want to run certain kinds of scripts. This might be the case because scripts can be downloaded through your browser and can perform a malicious action on your computer. So you might not always want that to happen, but if you disable those scripts, then they could also prevent certain functionality, or there might be some kind of whiz-bang feature on some web page that you really want to be able to see and enjoy. But if you disable the script, then you're not going to be allowed to run it. The other thing you could do is if the user has an administrator password, then they might be able to use those that require administrative approval. But as you can see here, many of these things will require you, they'll either be disabled or you'll have to be prompted for them or something like this, especially more dangerous ones, such as unsigned where'd they go? There it is. Download unsigned ActiveX controls. ActiveX can also perform certain functions on your computer, and so you might want to avoid those in certain situations, especially if they're unsigned. If they are signed ActiveX controls, that means that they have been validated as coming from the source that they claim to come from. Otherwise, an unsigned ActiveX control could be spoofed. It could say, I'm claiming to be from Microsoft, but I'm really not. Well, if it's signed as an ActiveX control, then it's confirmed that it absolutely must be. If it's unsigned, then you just have to take their word for it that it's really from Microsoft or whatever other company you would normally trust, but this ActiveX control in particular might be spoofed instead. So you have to determine what level of risk you're willing to take. If you're working with a customer's computer, there may also have been some kind of a virus or spyware or something that has gone through here and reset a lot of these security controls so that it's enabling unsigned ActiveX controls. And it's going to go ahead and enable ActiveX controls not marked as safe. And it can do that kind of thing because they want to open up your system to vulnerability to make you an easier target for other scripts or ActiveX controls they might have. Now then, let's go ahead and go back over here now to the Connections tab, and I want to point out two things. Number one, just as a quick troubleshooting tip, I don't think it's an A+ objective, but it does pop up, and that is when you have a user that complains that, yeah, they're on a cable modem or DSL or something else like a high-speed connection, and yet every time they double-click and open up their internet browser, it tries to dial out using a modem. That's probably because there's an old leftover in here from when they used to dial up, AOL, or when they used to dial up MSN, or some other internet service provider that used to be requiring a dial-up modem, and it's still in here. So you would select that and choose remove, and then they should be okay. Then the other thing that I wanted to really get to here is these LAN settings, because it tells us that we can configure proxy settings for all of this stuff. What's this all about? I'm going to leave this dialog box for a moment because I probably ought to describe, first of all, what a proxy server is. Now, there's several different brands of proxy servers. Microsoft came out with proxy server in several different versions in the past. Now that's really called ISA server, which stands for Internet Security and Acceleration Server. But there's also many other brands out there. Checkpoint, Cisco has various types of things as well, but there's very different ones. A proxy, by definition, takes the place of something else. So in this case, it takes the place of our network client. So if I'm on my computer right here and I want to access the internet, well, I don't directly access the internet. All of my traffic, sending and receiving to and from the internet, actually goes through a proxy server. This allows us to do then is to block or obscure my real ID. You see, I don't want the internet public to know what my own internal IP address is and other characteristics about my computer. So if I kind of wash everything through the proxy server, it filters everything, checks the packets, makes sure that everything is safe. It's not a sure solution for every kind of a threat or vulnerability, because I could still go to what we would think would be a safe website and contract a virus from it or something. But it at least conceals me in a general sense from the malicious internet, and it also blocks malicious traffic. Sometimes these firewalls, proxy servers, and other devices of this nature are able to identify inbound traffic that might have malicious content in it or that looks suspicious. And if that's the case, it can block that and prevent it from coming into my network. Also, we can block various inappropriate sites. I mean, let's face it, there are certainly places that you wouldn't want employees to go to in the workplace that might offend other coworkers. So proxy servers can kind of blacklist certain kinds of sites that would not be available otherwise. And then proxy servers can also log activity so that if somebody does try to go to one of those inappropriate websites, or it hasn't been added to our blacklist yet, we still know who went where and when and all of this. So it keeps accountability going there. And then it also helps to improve performance. This is really a big reason for having a proxy server in the larger corporation especially. Because what happens here is if I go to, let's say, Microsoft.com, but there's already been another employee who just went there on their same web browser, browser, then the proxy server, such as Microsoft's Internet Security and Acceleration Server, will cache that information for a while. Now, when I try to access that same content, it doesn't send my request all the way out to the internet and retrieve it from that web server. Instead, it delivers it directly from the ISA server's cached content, and we get a high performance boost locally, and we reduce our internet traffic. So those are the kinds of things that a proxy server can do for me. Now, how do I configure that? How do I tell my browser here to use a proxy server? Well, there might be some kind of configured client that you have to install on your local computer, and you might also have to configure some of these things where you can, number one, automatically detect settings, and this is configured in such a way that it will see if there's a proxy server on the network, and then automatically set things up for you. Or you can use a configuration script. So you would set up a web location, HTTP : and then the name of the server, for example, and that might have a script there that you can use. So if that's not the case, then you might also be able to use a manually configured proxy server here as well, and you will just give an IP address. Maybe it's at 10.10.10.68, and it's going to be on port whatever. By default, proxy servers are usually on port 8080, and then we can use this proxy server at this IP address for all of my internet traffic. I can also bypass that proxy server for local addresses, and that will help to reduce the load on that server because I might not need that if I am on a trusted network and I know I'm not going to go to any inappropriate websites if they're behind my own firewalls and within my own environment. Now quickly, let's go ahead and address some general troubleshooting issues. Now, almost as a general rule of thumb for nearly any kind of troubleshooting, always check the physical if there's any physical component involved. With networking, the most obvious thing there would be to make sure that your RJ45 plug is actually plugged into the jack. Make sure that the tab is up and it's locked into place, and that hasn't been broken off, for example, or something like this. So always check the physical, and then always check also the configuration. That's what I was talking about when we were here earlier by right-clicking on my network places, and when we went into our network connections, that means these settings here that we looked at a little while earlier. Make sure I've got my TCP/IP properties configured properly, especially if it's all in a static configuration, which means that I'm going to enter all that information in manually. Apart from physical disconnects, a large part of troubleshooting is because something has not been configured properly in the first place, and so it's just a matter of correcting that. Also, you can check out the LEDs. Now, network cards and network devices such as switches and hubs all act a little bit different. They might have a different legend or something determining what the actual meaning is of the various blinking lights and colors. So, for example, on most network cards, you'll probably see a yellow light, and if you stare at it long enough, it'll probably blink. In fact, some of them might blink every second or so. Well, what's that yellow light mean? Does that mean any kind of trouble or danger? No, that doesn't mean anything like that. What that says is that there's a collision on the network, which is common, and it's actually supposed to happen in a certain kind of way on Ethernet networks. Because you see, on Ethernet networks, all computers that want to communicate can do so at the same time. There's not any kind of rule that they have to wait their turn. However, when they do communicate on the wire at the same time, they can detect that that has happened. And when it does, they will then have a back-off interval where they'll wait a random period of time and then try to retransmit the packet that was colliding earlier. And then there will also be green LEDs, which normally means one link speed or that there is a link taking place and you're physically connected to something. Or you may also see red LEDs, and sometimes that'll just be a designation of a problem, or in some systems that will mean that it's just a slower speed connection. And then also make sure that you protect the cables. And this is for a couple of reasons. And that regards the preventive maintenance of your network cabling and securing your network cabling. You see, in highly secure environments, you really need to make sure that people cannot easily access that network cable, because it is possible to break into the network cable and to put a tap on it and to tap into the signals that are being sent back and forth between the computers. Someone could vulnerable your security that way, or make your security vulnerable. and then try to run that cable only in places where it's really designed or accommodating for that. So you would probably try to run your cable if it's overhead, like in above the ceiling tiles, for example. Normally there are going to be cable trays up there that will allow you to run the cable along them, but you wouldn't want to kind of just make your own path with the various cable and go around all kinds of fluorescent lights and maybe other electrical interference that could cause a problem. Also, another thing you can do is sometimes there might be a crimp in the cable. It might have been damaged. Somebody might have moved some furniture and crushed something. So use a cable tester to make sure that you have good connections on the plugs that have been made, they've been made properly, and also that there's not a break in one of the lines somewhere. This is just an example of a cable tester here, and you can use it for various types of cable. There's a plug at the top of this where you plug in, for example, both ends of an RJ45 jack, and you can also use it for phone jack, as you can see here. And when you actually run the test by pushing the button, certain lights will light up and there will be a legend from the manufacturer determining what those various lights mean. Also try to avoid any electrical interference, and I've talked about that enough in the past, but that would be around things like heavy machinery, something that might generate an electromagnetic field of some kind, light ballasts, and so forth. Now, you can also use the following kinds of troubleshooting tools according to the A+ exam objectives. There's a lot more tools than this, but this is what A+ calls for with a command line, and the first one there would be the ipconfig command. Now, the ipconfig command is one of those things you just access from a command prompt, and I just do an ipconfig. And by pressing enter then, I can see what my IP address is, my subnet mask, and my default gateway. Notice, however, that I don't get all of the information. Well, what's my DNS server configuration, for example? Let's go ahead and take a look at that. Well, you can do so by looking at various other parameters. And if I do an ipconfig space /?, I'll see that the ipconfig all switch will give me all the detailed information. So let's try that, ipconfig all. And by pressing that, now I see that I've got a DHCP server that comes up. I can see my physical address, lots of different information, what my DNS servers are, and when my lease was obtained and when it expires. So other very useful information in troubleshooting my systems. As an example of this, maybe I'm trying to locate another host on my network. Maybe it's a file server. I'm trying to do it by name, but I can't seem to be able to access it. And then when I go into my ipconfig all, I see that I'm configured to use this DNS server. Well, that might be one that's down for maintenance and I had forgotten about, or it might be one that's been decommissioned somehow and I need to change that IP address to something else. Might also be useful if I have an IP address configuration error, such as two conflicting addresses. Those would be two computers that have the exact same IP address. This will cause a little word balloon to appear in the notification area, and also cause an event log to appear as well. But in order to track down which computer is the duplicate one that also has the same exact IP address that I've got, I need to be able to identify MAC addresses. So that would be useful for that. And then also, I might be able to use ipconfig for some other things as well. One of the most common ones is I can do an ipconfig release. Now, why would I want to release my IP address and give myself basically nothing? The reason I would want to do that is if maybe I've got a DHCP server that had been offline and I was not able to get an address, or I got an address from a different DHCP server that I don't really want, for example, or from what we call a rogue DHCP server, where another server was accidentally put on the same network segment that I'm on, and I don't really want an IP address from it. Well, once I've gotten rid of that rogue one and I put the good one back on the network, or it comes back from maintenance, then maybe I can do an ipconfig renew once I've fixed whatever the problem is that I'm experiencing in our network problems here, and then it will give me this IP address and I'm back in business. And then another use of the ipconfig command might be that I want to flush, if I can type, flush DNS. Now, why would I want to do that? Well, you see, over time, as I browse the internet and access file servers and the like, it creates a cache of everything that it's been able to resolve using DNS in memory in a local cache. But it could be that one of the web servers that I accessed or one of the file servers has been moved now to a new IP address, and yet I have cached in memory the old IP address that I've accessed previously. Now, as a result, what's going to happen is when I try to access that server by name, it's really going to take me to the old IP IP address, and of course I'm not going to get service if it's not there anymore. So what I can do is to kind of give this whole thing amnesia, flush DNS, and it clears out the DNS resolver cache, and then next time it tries to locate one of those servers by names, it'll do a fresh query against a DNS server, and of course, hopefully we will have updated the DNS server to have the new information as well. You may have also heard of another tool called WinIP CFG or WinIP config. That's kind of a defunct tool. Any current versions of Windows no longer use that. Instead, we just use IP config. This old version that we used to use in previous versions would open up a graphical user interface to be able to configure all of this with, but really IP config is just fine. Now, we can also use a tool, a long-standing tool that we've used for a long time called the Packet Internetwork Groper. Sure enough, that's exactly what that means. But it sounds a lot like the ping of sonar from a submarine, right? Well, it is kind of the same way in the terms of how it works. So I can ping a host to see if I'm able to reach it. And I'll ping my server, dc1.accusource.local, and press enter. Now, I'm getting a reply back from it, so that tells me a couple of things. Number one, it does not have a firewall that's blocking that ping. Sometimes you will have firewalls that do that, such at various web servers, for example, because there are things called denial of service attacks that could happen, where somebody might take a whole bunch of computers that they've hijacked, and they might send out a kind of a ping flood against a server, and it's so busy answering the pings that you can bring it down. But for the most part, on a local area network, and it's not a public internet server, but a local area networks, usually you will probably get a response back. So then what does this actually mean? What this means is that it sends out something called an ICMP packet to this host, and it tells me also that it was able to resolve that name. So if I had tried to ping by name and was not ever able to get a response and it didn't translate it to an IP address, that would mean that either I'm not able to contact a DNS server to resolve the name, or the DNS server simply doesn't have an answer for me and it can't find one. And then it also tells me the time in milliseconds to get an answer back. And 1 millisecond is very fast. Of course, I'm almost directly connected. I only have one switch between these two hosts. If I tried to ping some other host, let's just see, for example, ping www.google.com, then we see here that we're getting 41 and 44 milliseconds because, of course, it's going across several more hops over the internet. Now, these are not unacceptable times. That's fine. But it's helpful if I'm trying to identify a slowdown, or if I'm getting extremely slow compared to other locations on the internet, then I might know that there's a problem there. Let's take a look at another scenario here with ping as well. What if I tried to ping a host by name and I wasn't able to do so, but I was able to ping it by IP address if I happen to know what the IP address is? So for example, earlier in my examples here, I pinged DC1. If I was not able to get a name resolved to an IP address here, but I happen to have memorized what that was and I knew I could ping that IP address, then I might type ping 10.10.10.5, and here I'm getting an answer. Whereas earlier, maybe with a name, it never gave me an answer. That would mean that there was a problem with DNS, once again, meaning that the DNS server is either offline or there's no record for dc1.accusource.local. Now, it might be that I'm getting traffic from a host that I don't recognize. If I'm getting IP address traffic from, say, 10.10.10.37, but I didn't establish any connections with them, I don't know who they are they trying to hack into my computer? For any other reason, I might just need to know the name of that computer. And if I don't know it already, of course, then I can type a ping, but this time I'll put a switch in there of a -A, 10.10.10.37, and I say, who in the world is this guy? And then it will answer me. Win64, oh, that's right, that's my 64-bit Windows machine. There must be some utility running on it that's scanning the network to search for viruses and stuff like that. So maybe it's doing something legitimate. On the other hand, maybe it's doing something that I don't want it to do, but at least now I know which computer it is. Another useful command I have at my disposal is one called traceroute, which will identify the hops between my local computer here and the destination host I'm trying to reach. So for example, I might want to see what the route is between here and yahoo.com, and I see it goes through my Linksys router here, and then through my ISP's private address, and then through several other IP addresses belonging to my ISP here, until it gets to eventually Yahoo servers of some kind, and so it kind of maps this out for me as to which hops it's going through as it gets to the destination. Now, most of these in between are going to be routers, but of course the final destinations here are going to be the actual server itself. Now, if I'm experiencing network difficulty somewhere along this path, some of these numbers will be either pretty high or they'll just give me a star there, meaning that it tried to penetrate through that particular location and it just timed out. It was not able to do so within a reasonable amount of time. That's not always a cause for concern if all the stars appear at the bottom of the list, and I did this in the background because I knew it would take a while. But for example, not all hosts will allow you to run a trace route against the destination. That might be for security purposes. For example, Microsoft.com here does not allow us to run a trace route directly against their server. So I can go through my own ISP, but once I get to Microsoft equipment, apparently, they don't allow traceroute to go through, so it keeps trying, and it's just not going to. Now, what I can do here, if I know it's not going to get any further anyway, I'll just Control-C to kill it, and then I'll be done. So that was the traceroute command, and I also have a tool called NSLookup. Now, NSLookup is useful for name server queries, and I could do something like NSLookup www.yahoo.com, and I want to use this to identify which DNS server is resolving a name for me. And this tells me that my local DC1 server on accusource.local in that domain, that's the server that resolved www.yahoo.com, and this is the IP address of that server. Now it says non-authoritative answer. This means that my own DNS server does not actually have the information in its own zones or in its own database of zones, which is information that contains name to IP address resolution. Instead, it had to go to some other DNS server to get the information, and when it got it, it passed it back to me. Now here is what the answer is. I'm trying to find www.yahoo.com. Where is it located? It's located at 209.131.36.158. Notice that here it says that it was an alias for www.yahoo.com. That means that when I go to this name right here, I'm not going to a physical server that's really named www.yahoo.com. It's really named this. And then there's a special kind of a record, a resource record in DNS that will translate any requests that go to www.yahoo.com to this physical server on this IP address. And it does that, kind of giving it a fake identity that's easier to remember so that my users don't have to remember all this weird stuff to type in. Now, that's one way of running the NSLookup command. Another way of doing it is I could run it in interactive mode, which would be NSLookup and press enter. Now I'm on an NSLookup command line, and one of the things I could do now is to set the type of records that I'm looking for. Let me just do a question mark, and you can see that you can do all kinds of different parameters with this. You don't have to memorize these, but just know the basic function of what NSLookup is for. So, for example, if I wanted to do set type equals MX. That would mean that I want to find out who your mail servers are. So then I would do a set, and once I've done that, I'll type in, Google.com, and the Google.com mail servers are all these servers that we have right here at these IP addresses. Now I know where their mail servers are. So a lot of troubleshooting is really gathering the appropriate information. The more I can research and the more I can learn about name servers and what kinds of servers I'm looking for and so forth, the more likely I am to be able to get to the bottom of the issue. And to get out of NSLookup here, then I would type exit. And of course, I'm going to exit the command prompt here now as well. In this nugget, we took a look at networking, and this was part 5, where we started off with a discussion of work groups and domains. Remember, a work group is primarily the same as a peer-to-peer network, and a domain is primarily the same as a client-server network in that the server is a centralized location for our accounts. Then we took a look at how multiple domains can comprise a tree. We also took a look at DNS and how it works, and how much easier it is to know about names than it is to memorize a bunch of IP addresses. And then we took a look at the basic network configuration, and that's going to be very important because in troubleshooting, the biggest part of it is something that might be misconfigured. So as long as you configure this right, you've taken care of a lot of potential troubleshooting issues. And then we talked about browser configuration to avoid scripts from running and to configure proxies, and we discussed what proxies were. We also took a look at troubleshooting issues at the end, including several command line tools that are very useful. Well, I hope this has been informative for you, and I'd like to thank you for viewing.